So I'm a pretty active member of the Society of Creative Anachronisms, and a few weeks ago I made these. But before I describe what they are, I am clearly in the wrong clothes. And where was I? Right. So, if I remember correctly from the Herald, it went something like this. This does open the premier court of their Royal Majesties Rex, Gabriel, et Regina, Sonia, April 7th, Anno Societatis 51, that being the Gregorian year 2017. Yes, that's about it. For those that don't know what I just said, some friends of mine happen to have become king and queen of Ansteorra. Ansteorra is, well, that chunk of the United States. And as a gift, I made them the thing I showed you earlier, which is that thing right there. It's a really fun little project. It was the first time I worked with brass trying to do anything more than experiment. And you know what? Let's just kind of go through the cam and then let's make some chips or dust. Because 1mm bits make dust, not really chips. Here we are in Fusion 360. We're going to try to go over the CAD and the cam relatively quickly. There was 3-4 operations involved, so it might drag a little bit here. But we'll get to cutting chips at the end. You get to watch that happen for sure. So stick around, learn a little Fusion 360, and then of course watch the chips fly or dust. Like I said, 1mm bits don't make chips; they make dust. Kind of a bear to clean up. Anyways, so this is the end result we want. This is actually not the exact end result we want, but this is the end result we CAD. We started from a sketch, and I'm throwing up here the sketch here. You'll see we're going to use a chamfered bit, actually a mill and drill, 90-degree mill and drill, and we're going to use the engrave feature in Fusion 360 cam to mill out those parts, and we're going to use it also to mill out the star to give the star kind of a cool accent. Could have done, I mean, essentially this is like art cam type work, but I needed to set up softjaws, and there were moving material around between positions. That's probably beyond the scope of art cam, so I think Fusion 360 was totally the right choice here. So here's our cut crown. This is our kind of finished goal. We went there through a couple of steps. The first thing I actually had to do was I had to tell the cam I wanted to cut this shape out. This is the profile. And this I'm going to mill out of the top of a piece of 1/4 inch by 1.5 inch by 3 inch brass stock. So that's the stock is going to be 1.5 by 1/4 by 3 inch. This is an 1/8 inch piece, so it's going to cut an 1/8 inch off and make that part. So I'm gonna end up making 3 of these because, well, 1 to spare. I needed 2 and I wanted to spare just in case I failed somewhere in the process. Once we make that piece, we actually need to tell the cam when we go to some of the other operations the actual stock that's left over. Well, the shape of the stock that's left over is not that. The shape of the stock that's left over that we care about is actually this shape here. So there's that part we're gonna mill out, and that's the excess of the 1/4 inch thick piece of stock, right? That's the remainder 1/4 inch, right? We cut this is an 1/8 inch thick, so that leaves us an 1/8 inch up there. So that we need that stock. Now, why do we need that stock? Well, we're going to top off the part. Well, so we're going to top off the part, and then we're going to do all our milling from the top. So if you follow me here, we're going to start with a solid piece of brass, and we're going to tell it to cut out this shape. And once that shape's cut out, we're going to get a piece of stock that looks like this. Cute. And we're going to stick that in some softjaws. So here's my softjaws. We're going to stick it in these softjaws here that we're going to also mill out during the process. So there it is, stuck in the softjaws. And then that's our stock, which we'll set in the cam. And we'll tell the cam that we want to make this shape out of this stock. So I know that's a little crazy sounding, But that's why there's so many parts going on here. That's why we have the soft jaws, and that's why we have the solid crown and the crown stock, and then our eventual final part. So, kind of gives you an idea what's going on in the cam. Let's go ahead and jump over the CAD. Let's go ahead and jump over the cam real quick. I'm going to go ahead and generate all the tool paths. They may take a little while they're generating. Let's go ahead and turn off the bodies. So these are all the bodies we've got going on. We can ignore that error. You notice some of the stuff is running slower. Those are really small 1/16 of an inch and 1 millimeter jobs, and they're running after some other ones because we want to do some rest milling so that we're not reinventing the wheel, as it were. Right, so let's start at the beginning. Crown stock, this is our piece of stock. This is, if we go review this, our stock is 1.5 by 3 by just a hair over 1/4 inch thick. And our model is a few thousandths beneath the top. I'm going to surface the top. I want to make a nice flat surface right for the top. We're going to surface that material. Then we're going to adaptive. This is just a 2D adaptive. No, it's a 3D adaptive. So we're going to 3D adaptive, remove excess material. Then we're going to hit it with a 1/16 inch using rest milling to cut away these parts that the 1/4 inch bit couldn't finish. And then 2 passes with a 1/16 inch contour, because as John Sanders from NYC CNC says, deflection is a real thing. So even though if we look at our adaptives and material remaining, if we look at our adaptives and the material remaining, we're only leaving 1/1000th of an inch. So I'm still going to take 2 passes. I'll take 1/1000th, and then I'll take whatever's left, just in case there's anything. Let's talk feeds and speeds. The feeds and speeds, this was wrong. I ran it and I ended up dropping it down to about 40. I did not realize that's totally a typo. I did run 10,000 RPM, and I was supposed to be running more like 30 to 40, not 90. I think I was playing with 20,000 RPM settings, and I forgot to change the spindle speed, and I just upped the feet per second. I could hear it chatter, and I turned it down. It never broke the bit. The bit didn't care. The machine didn't care, but it was pretty noisy, and I didn't like it. So I did run it at about 40 at 10,000 RPM. Very happy with that 1/4 inch bit. The adaptive is 22,000 RPM, 20 inches a minute. Now, 20,000 RPM sounds like a lot, but the smaller your bit, the faster your spindle has to go, or the slower you have to go. Smaller bits, surface feet on that end mill becomes less because obviously you have a smaller radius. So surface feet is a huge factor in cutting, especially on the face of the mill. So actually in the edges of the mill, right? Because there's a less diameter. So the point is that if you get smaller bits, you have to go faster and faster and faster. So having a high-speed spindle is great if you want to go fast at things like this. Go faster. I probably could have gone more than 20 inches a minute. I was trying to be a little safe. My depth of cut and my engagement in my adaptives are super conservative. I was doing 1/100th of an inch by 1/100th of an inch. So 1/100th of an inch radial engagement. That's the edge of the bit, and 1/100th of an inch down or depth of cut. Considering the whole bit is what 1/16th of an inch is really small. 0.31. Somebody's going to correct me. 1/8 is 12. So 6/100ths of an inch. 6.0625. Anyways, point is they're small. Taking 1/100th of an inch, being conservative but safe. All right, so as we all like to do, let's go ahead and generate a toolpath real quick. And simulation. We're going to turn off the toolpath. We're going to show the stock, and we'll run this pretty fast. You'll see here, surface the top. There's that adaptive going, and let's turn off the tool holder. Why do we show the holder? There's the final bit. We'll back up and let's go back in operation. Let's go back 2 operations. Yeah, let you see it a little slower. So this is what we're going to do, right? That's the adaptive. It's going to run a couple of passes. I think I was taking a 1/16 of an inch depth of cut on these. You know, if I was making more than 3 of these, I probably would have, it was being persnickety sometimes. And then there's those cleanups. And we're good to go. The next step we had to do, so that was us, we did that 3 times. The next thing we need to do is we need to make our soft jaws. So that's a 1/4 inch adaptive into aluminum, then a rest adaptive with a 1/16 of an inch bit. Again, another 1/16 of an inch bit, trying to get into those small areas to really snug shape tight. And then a couple of contours. I actually don't know why there's so many of them here. Oh, no, now I remember why. So I have my original contour, which is exactly following the path, and then I did an offset contour by 1/1000th, 1/1000th and a half, and 2/1000ths. I ended up not needing any of these, but I wanted to have slightly bigger sizes so I could walk my way into the piece. Another thing I watched from John Sanders when he was talking about doing soft jaws, he likes to walk it in, so he'll start exactly at the right size. If the piece fits, awesome. If not, he kind of ups the size very small amounts, because the last thing you want is the piece to be loose. First cut was perfect. It fit absolutely perfectly. My plan was, from Grimsmo knives, he mentioned that sometimes you run the same contour and get like a little 1/1000th or 1/4 of a thousandth off. So my first plan was run the exact same contour. If it didn't work, if that didn't work, then go a little bigger. But everything worked perfectly right off the first contour. So adaptive, rest, and then single contour is all we ended up doing. Now crown finishing, this is where it gets a little tricky. Remember that funky stock I was talking about? So here, if we look at this configuration, we actually set the stock to be a solid, and the solid we set was that crown stock. So this is the remainder of the part coming off of cutting the crown away. So that's what's going on there. Then we go ahead and face off that 1/8 of an inch of material with a 1/2 inch bit, just because I hadn't used the 1/2 inch bit and I wanted to play with it. It did a beautiful job. 45 inches a minute, 12,000 RPM. That was kind of what I should have been doing with a 1/4 inch bit as well. It was a beautiful pass, and I was doing step over was way shallower than it needed to be, and my maximum depth of cut was 3/100ths of an inch. It's not enough, not much, basically about 1/16 of an inch cut, a little less. Then we did our adaptive. Now this adaptive is with a 1mm bit. So this took a long time, but was really able to do these detail work even tighter than the 1/16 of an inch bit could do. It was really, really cool to work with a 1mm bit. If we look at our feeds and speeds here, 20,000 RPM, 20 inches a minute, same kind of thing. Our engagements were the same as well. 100th of an inch radial engagement and 100th of an inch depth of cut. So that worked out really well actually. And it's going to take a little while. We went ahead and used him. You could see that, how much is going into that computing that toolpath. Same kind of thing to cut out the center of the star. I didn't want the star with. I didn't want the engraving to go too deep, because how the engraving works is it basically follows the shape and tries to use as much of the bit as possible. So it'll go pretty darn deep following a shape with the engraving cam. And I didn't want it to do that. So I wanted to hollow out a bit of the star so I could just engrave around it. And here is the engraving pass I'm talking about. So you can see kind of how they go deep into the body of it as they need to make their shapes. Run the engraving pass twice. This is a trick I learned from somebody who's a lot more experienced than me. I don't remember the name of his channel, but he mentioned that when you engrave, you can get burrs. So run your engravings twice, basically one to cut everything and the second one to clean it up. Again, as John Sanders from NYC CNC says, there's tool deflection. It's not really a tool deflection scenario, but it's close enough. And when we're done, we go ahead and shape for the outside edges just to shape or break them and make it look nice. So if we generate this toolpath real quick, we can check out the simulation. So, right, let's make sure flute only, stock, and let's go ahead and hit play. And we'll speed this up a little bit. There we are, surfacing. We're going to do this a few passes. I'm going to a little bit more. And we'll turn it back down a little bit here in a second. So once it's done surfacing, which I think this is the last pass, you can see there we are, cutting everything out with that 1mm bit. And once we like how everything looks cut out with a 1mm bit, we'll come in and so it did give a few warnings in here of collisions. It was colliding with the softjaws. I actually have the softjaws set here, but it was colliding at like, you know, 1/1000th of an inch, which basically means it was going to, you know, polish a chunk of the soft jaw. That's more than fine, so it wasn't an issue. Always good to check out your reds, though. If you see reds, definitely, you know, check out what's going on there. You don't want to break a bit, and with a 1mm bit, it's really easy. They're really easy to break. And so there's that. So there's that engraving step there that you see, and then the engraving step running twice, and finishing off with the Schaefer. So this is, you know, gives you an idea, really good idea of what that engraving does. You can see how it's cutting as deep as it can to get those edge shapes, to get as close as it can, and then it cuts from the other side to get the rest of them. Really love the look of that feature. All right, let's make some chips and some dust, man. Right, sorry. You know, I'm starting to think that people who say that you can't cut metal with the CNC router haven't tried. Now, I'll admit that my tolerances weren't perfect. I was off by 0.003. So, all things considered, they could have been better, but the results were fantastic and they were really well received. So, if you got a CNC router and you're like, can I cut brass? The answer is yes. And you can do really cool things. If you have something you want me to give a shot to, give it a try, throw a comment. And as always, please subscribe. Thanks. Bye.